Hello everyone and welcome to part 6 of the Akim 2020 virtual trek. Today we'll be doing some really exciting stuff and talking about geology and geography. Yes, I know you're on tenterhooks, so we better get started. Well, we finished our last session over here at the Leopard Temple in the Uvda Valley, and this aerial shot gives us a very nice view of the Uvda Valley here. And here is the airbase and the other airbase. There's Shacharut, where the Six Senses hotel is. We're going to take Road 12 back north, north being to our left, to Nelson Junction. Then we're going to take a right back down into the Arava Valley. But before we get all the way down into the valley and hit Road 90, we're going to stop at a lookout point known as Har Ayit, appropriately Eagle Hill. So flying over there, we arrive. Now what I love about this shot is that this virtual image is almost identical to this photograph I took at Eagle Hill a few months ago. Look at that, remarkable. Anyway, what are we looking at? Firstly, in the distance, we can see the mountains of Edom in Jordan. This is the Arava Valley. This is Jordan. This is Israel. These are the fields of Kibbutz Lotan. Lotan itself is just here on the right. Let's talk a moment about the border between Israel and Jordan. And we'll see it better if we go aerial again. This is the border here, this white line, running down straight, running up from the south straight, with this strange blita, this strange bulge into what would seem to be naturally Jordanian territory. How did that come about, I ask? Well, to understand the Israel-Jordan border, we have to go back to 1949, when, as we talked about in the first part of our journey, the armistice agreement was signed between Israel and Jordan. The armistice agreement laid down an armistice line, but not an international border. We wouldn't have an international border until we had a peace treaty with Jordan and an internationally recognized border. Now in the 50s, a few of Israel here and there, let's just say, expropriated bits of Jordanian land, a few kilometers, square kilometers here and there, with the acquiescence of Jordan, I would say, in places like Lotan, where there was no one around to see it and no one around to care. In other places up north, it was more problematic, for instance, at Naharaim, where Israel held land on the Jordanian side of the armistice line. This went on for decades until in the late 80s and early 90s, Israel and Jordan sat down to write and prepare a peace agreement. And as part of that peace agreement, they had to agree on the international borders. So suddenly these little extrusions became an issue. They were dealt with in two ways. The first way was giving Israel a 25-year lease on the land. And that applied to land in Naharaim and land near a kibbutz called Sofar, about 60, 70 kilometers north of this site. The land, that agreement, that peace treaty was signed in 1994. So in theory, in 2019, we were meant to return it to Jordan. At the time they wrote the treaty, no doubt both sides thought that things would be hunky-dory and Jordan would just release the land and everyone's honor would be satisfied. Jordan would still be the nominal sovereign of the land and Israel would get to use it. However, in 2018, diplomatic relations between Israel and Jordan were really not that good. Mostly related to the Palestinian issue. I don't want to get into the politics of it, obviously. And Jordan decided it had to make a show and inform Israel that it will not be renewing the lease. And there's nothing we could do about it, really. We could have tried enticements, whatever, but we didn't succeed. And indeed, at the end of 2019, in November or December, and some of you will remember, it wasn't that long ago, Israel returned to Jordan 2 parcels of land, one at Sofar and one at Naharaim. The gates were closed, the keys were, and they were locked, and Jordanian holds the key. Some other of these bulges were dealt with in a different manner, like this one. Israel and Jordan basically did land swaps. We gave them a little bulge into Israel, and they gave us a little bulge into Jordan. And that's why rather than following what might have been the natural borderline along this seasonal stream, the border has this bulge into Jordan. Now let's go back and talk geology. I want to talk about, firstly, how the Arava Valley formed and how the mountains got these lines, these very obvious lines of color, this black, this red, this white, which are also on the mountains on this side, but we don't see them as well because we're standing on them. How did this all occur? And to understand, we really have to talk about plate tectonics, because unlike some other valleys like the Mississippi Valley or the Grand Canyon, the Arava Valley was not caused by the erosion as a result of a river flowing through it. We have no river in the Arava Valley. And the Jordan River up north was never so significant that it could create a huge valley like that. So like I say, we have to talk about plate tectonics. Now, what are plate tectonics? That is the science or the branch of geology that discusses how the surface of the earth is made of very large rock plates, if you will, that are floating around and moving around. Israel sits on a part of the Sinai African plate, as you can see here. Jordan sits on a part of the Arabian plate, just there. Now, until about 22 million years ago, these plates were in fact one plate and moving together. Then, because of the various forces, it snapped apart. Since that time, 22 million years ago, the Arabian plate has been moving north relative to the African plate at a rate of 4.7 millimeters a year. Yeah. Now, I say relative to us because, in fact, we're both moving north. We are also moving north. That is moving north. But they are moving north faster than we are. Now, if you times 4.7 millimeters a year by 22 million years, you end up with a distance of 105 kilometers. So you would expect to find that geological features on the Jordanian side are 105 kilometers further north than the same features on our side. And that is indeed the case. For instance, timber mines, copper mines, are matched on the Jordanian side at a place called Funan, about 105 kilometers to the north. Of course, geology, like life, is never so simple, and that's the only philosophy we're having in this particular presentation. And the plates didn't just move past each other as shown in this picture. By the way, when tectonic plates move past each other, that type of fault is known as a transform, as marked on the map here, the Dead Sea transform. There are other types of faults. For instance, subduction fault is when two plates abut each other and one is forced down below the other, subduced. It's a subduction fault. We don't have that. We have a transform. But this transform didn't just slide along each other. About 5 million years ago, it started to pull apart a bit and lift up like that. About that time, the Arabian and Sinai plate tilted a bit down towards the Dead Sea. And this plate, the Arabian plate, lifted up a bit and it shattered, if you want, along that line. We see that better if we look at the faults in our region. That last picture showed you the broad picture of the faults, but rock is not a nice material and doesn't shatter along a nice clean line. If you pick a piece of glass up or a piece of stone or concrete and drop it, it's going to break up in lots of little bits. And that's what the Earth's crust does when it fractures along a fault. It's a brittle material and it doesn't break along a long clean line. We end up with all these little faults. And these are all the faults, geological faults in our area. This isn't here to scare you, although perhaps it should, because we're due for a major earthquake. This is the Dead Sea transform running along here, made up of lots and lots and lots of small faults. And these faults explain a lot of the geological features we see in our area. For instance, this one, another fault runs at the back of the Carmel Mountains. That's why the back of the Carmel Mountains has a steep fall into the Jezreel Valley, which is really a subsided valley caused by this geological fault from the ones to the north. The Dead Sea and the Kinneret, how did they form? Well, as I said, these faults are not only multiple and in small bits, but they're also not straight. So instead of having a nice smooth motion along the transform, you had a kink in it. And when that kink opened, you ended up with a hole known as a pull-apart basin, and that's the Dead Sea, a pull-apart basin, as is the Kinneret. The same thing in reverse happened when these kinks abutted one another as the transform moved that way. Well, I should turn around. So imagine I turned around. The kinks in the transform hit each other. There's nowhere for the Earth to go other than up, and it buckles. That's how we got Mali Gilboa and the Hermon. But we're talking about the Arava. What other features do we see in the Arava? Well, this is the Notsa Ridge. This fault here is next to Kibbutz Paran, which is about here. It's called the Notsa Ridge. And it's the highest point in the Arava Valley at about 240 meters. Now, we know the Dead Sea is at minus 430 meters today. We know the Gulf of Eilat is at 0 meters. It's at sea level. So from the Gulf of Eilat, if you drive up the Arava, you actually go uphill for the first 100 or so kilometers to the height of about 240 kilometers, and then downhill to the Dead Sea. If you recall the plan to build the Red Dead Canal, it would have meant that for the first 100 kilometers or so, the water would actually have been pumped uphill before it could run downhill to generate hydroelectricity. Now let's look a bit more closer in this area, and I'd like to try and understand what happens when these plates pulled apart and lifted. And this is a cross section. This Eilat would have been here. We're looking from the south. Eilat would have been here. This is the Gulf of Eilat. These are the mountains of Edom. These are the mountains of Eilat. Now, I mentioned that the Arabian plate lifted up and ours tilted a bit. That explains why the Harei Edom reach a height of almost 1,500 meters. If you're standing in Eilat and you look at the mountains of Jordan, you can see they are much higher than the ones in Eilat. On our side, the highest mountains over here only reach about 770 meters. When these plates pulled apart, forming this valley, it's not as if suddenly you have an abyss to hell to the center of the Earth. It doesn't work like that. You get slip faults, just like we saw when we were in next to Amram's pillars, but on a much larger scale. The rock breaks along several lines, as we saw here, several parallel lines, and blocks of rock subside. Where they subside, you get valleys, and where they stay up, you get mountains. In geological speak, the subsidence rocks are called graben. The ones that stayed up are called horsts. Now, geologists, just like lawyers or archaeologists, think that if they use words unique to their profession, they can maintain a mystery about it. But graben, all it means is a ditch or a trench. And horst is just a pile in German. Graben, think of the word grave or gravlux, salmon gravlux. The reason it's called gravlux, by the way, is because the Swedish used to make it by digging a trench in the beach, laying the salmon in it, piling on salt and covering it again. And it would cure in the sand in a grave, in a trench, gravlux. So, and back to the Arava, sorry for that diversion. So you have graben, you have horst. Over time with erosion, the graben would fill with alluvial matter and form the layers of salt and sand that we see in the Arava Valley today. This isn't static, by the way. The Arava is still sinking. And this is still rising, I believe at about 1 millimeter a year. What are all the colors that we saw as well on the mountains that we mentioned a moment ago? Let's go and look at it again. What are all these colors, these lines? How did they form? Well, they were exposed, first of all, by the fact that we had this fault pulling apart and the graben dropping, subsiding, revealing the colors along the fault line. What are the different colors and what do they mean? Well, the bottom layer, is the dark layer, is mostly igneous rock, consisting of rocks called basalt and gabbro. Now, basalt and gabbro are a type of rock, an igneous rock, known as mafic or plutonic. Good word, that, plutonic, because it's a rock that comes from the depths of hell, meaning very deep down. And it has a lot of magnesium in it, that's why it's called mafic. This type of rock forms normally at a mid-ocean ridge. You've probably seen pictures of it. The magma comes up and then spreads out and the ocean floor gets forced apart. creating a new tectonic plate. Now, as this happens, the magma solidifies and you get basalt and gabbro rock. This happened hundreds and hundreds and hundreds of millions of years ago. About 600 to 800 million years ago, however, in the Precambrian era, this mass of rock lifted out of the ocean and was exposed to air and fluvial action. One of my favorite words, say it with me, fluvial. Fluvial action, which eroded this rough rock surface and created a rather flat surface, which in geological speak, they've got a word for everything, is called the peneplain, which means almost flat plain. Okay? Think penultimate, almost the last. Peneplain, almost flat plain. Then, all those bits of rock that had been broken off by the fluvial action started to settle on the peneplain and formed sandstone. Then, about 250 million years ago, that sandstone, the plates subsided together and was under an ocean known as Yum Thetis, the Thetis Sea. And while it was under the ocean, all these little sea creatures died for our benefit and produced a layer of limestone on top of the sandstone. So you have a top layer of limestone over a layer of sandstone, over a layer of igneous basalt and gabbro. And those are the three colors that we see. Later, of course, water would rush along here and create those alluvial fans we saw before and bring sediment into the Arava Valley, and that's what all this is, filling in the gaps above the graben. So now you can speak geological speak too. By the way, there are many other geological features in Israel that you know of that can be described as horsts of graben. For instance, Masada is a horst. Mount Tabor is a horst. Jezreel Valley is mostly a graben. There you go. Impress your friends and neighbors. So here's a picture again. We can see the lower layer in the mountains of Edom. That's the igneous basalt gabbro peneplain. Above that, the sandstone. Above that, the limestone. We see it better close up. This is, again, the picture of us walking into Nahal Shoret, the dark igneous peneplain rocks. Above that, a thick layer of sandstone, and at the very top, a cap of limestone. This is my friend Arya sitting on the peneplain. That's this dark rock here. Above him are multiple layers of sandstone. Now, it's interesting to note that some of the sandstone has big rocks in it, in the conglomerate, and some only have little rocks. That suggests that at this point in history, the fluvial action was very strong, carrying big rocks. By here, it had come down somewhat. By here, it was non-existent, because up here, we have the limestone. By here, we were underwater. Now, there are many other periods of time. I don't want to go into it, when lakes came back and we went up and down, and there's a bit of chalk and a bit of this. But that's the general picture. I'm sure you've heard enough geology today. Now, I mentioned that the Precambrian rocks are, the peneplain is 600 to 800 million years old. That's the oldest exposed rock in Israel. Now, don't be too impressed, because in Finland, for instance, there are surface rocks that are 3.3 billion years old. Yep, not bad at all. Anyway, that's the end of today's presentation. Hope you enjoyed it. We'll continue with our tour shortly.